Thank you, sir, for giving me this opportunity to speak about my experience with Earth Engine and the approach I took in Earth India Challenge 2018. So myself is Soumya. I was a runner-up in Google Earth India Challenge 2018 that was conducted last year. So I'm a integrated MTech student in Geoinformatics, Central Jharkhand, Ranchi. So I would speak about why I love Earth Engine. The main reasons why I love Earth Engine. I was introduced to Earth Engine about a few months back. I didn't knew about Earth Engine. I heard about Earth Engine, but I didn't knew much about Earth Engine. So the main reasons why I love Earth Engine, fell in love with Earth Engine is it significantly decreased my dependence on scattered spatial data, which is generally very spatial data is very scattered in the web. You have to search for data such as precipitation, temperature, everything. But here it's clustered in everything is into one platform. So it's also running huge and very huge geospatial analysis in seconds, supported by Google's cloud infrastructure. You don't have to just wait for the big processing that you have to wait in your laptop. If it's good enough, it will take seconds. Now anybody can solely work on analysis without even have to downloading huge data sets and caring about what your system capability is. It also gives the ability to customize and automate geospatial workflows using JavaScript, Python API. So it's very good platform, and one of my its favorite. Now it's my favorite. So I will continue to work with this platform. So I would also talk about what the approach and submission I did, which was awarded. So that the main challenge was to improve the land use land cover classification using techniques. So I used multimodal data fusion, spectral indices, and hyperparameter tuning of random forest algorithm to improve the accuracy of landfall classification, and it was significantly improved. So these are the approach I took. Multimodal data fusion is when we fuse multiple modes of data, such as there is SAR, there is multispectral bands. I took SAR VV polarization, that is ascending and descending pass, both side, and I took all multispectral bands. Then I also took the ALOS DSM, that is elevation data, slope and aspect. From elevation, we can find slope and aspect. That are two bands. And spectral indices and PCA also I took. These are the PCA's principal component analysis. I took the principal component 1, which has maximum amount of information. We took the modified normalized difference water index, right? Which is these things actually the algorithm finds these, but every indices have a particular value for every feature. Therefore, they have different values. From that, the algorithm finds the relations between variables. That we use the normalized difference vegetation index for vegetation. Generally, NDVI have a range of values for every type of feature on the surface, and I also took the bare soil index. The most confused feature on the surface is bare soil. The bare soil is generally confused by algorithms. The algorithms get confused with bare soil because its spectral signature match with nearly when it starts and when it ends, it doesn't generally find out. Therefore, I used a bare soil index for that, so that it will be specific for the algorithm to find out. And also hyperparameter tuning of random forest algorithm. Hyperparameter tuning is we tune the for random forest. It's finding a best parameter that works that gives the maximum performance. So for random forest, there is number of trees. At particular number of trees, it performs best. So we find the best number of trees. I wrote a function that finds the best number of tree at which the performance is optimized. So these are the approaches. So future work with Earth Engine as a geoinformatics student it's actually my day-to-day job to work with huge geospatial data. So it's a great gift by Google for students like me who lacks in computational resources. Doing huge geospatial processing, you require huge computational power. So I really have a crappy laptop. So it's a great gift as it gives results in seconds. Often use Earth Engine, it's easily lets you convert your ideas into code. I love coding, so it's easily lets you convert your ideas into code and that to solutions, real time solutions on the ground. So my primary research area in which I love to work is deep learning, automating geospatial workflows. Geospatial workflows needs complex uh, operations to get the final results. Therefore, I try to automate those processes using deep learning. So I'm quite excited. In the in the summit. In the summit, I got a huge idea about TensorFlow and its integration with Earth Engine. So I'm quite excited about integration of Earth Engine deep learning in my future works. I would be very excited. So in my future works, in my MTech project also, I would continue with Earth Engine, with working with Earth Engine. The conclusion, Earth Engine is a very, very powerful platform for fast, huge geospatial analysis. It's very good platform. LULC classification accuracy can be significantly increased as we got the idea of the challenge by fusion of multiple data, spectral indices, and hyperparameter tuning of algorithms. Awesome learning experience in the Earth and India challenge during solving the problem and also in the summit. Thank you very much for giving me this opportunity.